We were just witnessing some stalls and delays with just common page refresh in our My Campus portal. And this really gets back to the need for Wireshark as a forensic tool. And what was the last constraint or consideration we mentioned as we closed out class on Tuesday about the setup for Wireshark? Does anyone recall any of the required configurations? Would anyone care to volunteer? There was something specific about the host that's running Wireshark. Can anyone recall the specifics about what you have to change on the host that's running Wireshark? Anyone? Can somebody unmute your mic to tell me that we're still breathing or I still have an active connection?
Yeah, we still hear you.
Okay, all right. Does mention of the word promiscuous mode ring a bell?
Yes, it does.
Okay, can someone explain more about what that term means, please? I'm not trying to be difficult. We're trying to deep process some of the most important aspects of network forensics that, are showstoppers, right? We would want you to have good form in your initial experiences with Wireshark, and you wouldn't want people to quickly conclude novice status, right? Newbie status. I'm going to explain a little bit more about promiscuous mode because I think it would be beneficial and it would be another way of coming at this concept, and it would also provide additional information, okay? Everybody with me? So the nature of a network switch, a network switch by default tends to watch exclusively for the MAC address associated with a physical port. Okay. Does everyone recall the stuff we had on the screen? It was about span ports, right? I went to Google and I did this.
Yeah, span ports and mirroring.
Yeah. And yes, there are subtle distinctions, but essentially, I think I clicked on this one here. So you have a monitoring device, it's Wireshark. Ordinarily, a switch differs from a hub in that each of the physical ports on the switch in the MAC address table and in the ARP cache, right? The MAC address of the interface that's connected physically to that port is associated with that port. So there's a physical port to MAC address association. It is not a MAC address to IP association. That's what happens on layer 3, okay? What switches are designed to do intentionally is to isolate the traffic on each. So there's a Ethernet by design is broadcast. So whenever you're connected to Ethernet, that's the same as wireless. It's broadcast. And on an old hub, if an old hub is basically a multi-port repeater. So if a host is sending and receiving traffic, it goes to the hub and then it's repeated to all the other ports on the network. So everybody sees it. It's broadcast, just like broadcasting your voice at a house party, right? It's broadcast, or broadcasting with the radio. That caused all sorts of network exposures early in the history of the technology industry, where engineers came back and they said, okay, first of all, there's too much contention. They're all sharing the same space and bandwidth. And if we have to keep repeating each of the packets for everybody, or frames for everybody, right? On layer 2, it's frames. On layer 3, it's packets. We have to keep repeating all that stuff to everybody. We're taking up extra space. In a sense, we're sharing the same bandwidth. So if each port is 10 megabits or 100 megabits or 1,000 megabits, which we would call a gigabit, right? Everybody on a hub is sharing the same gigabit network transmission space. It's called the broadcast domain. That causes a problem. It reduces the bandwidth available, but it also creates a lot of contention. And so a network switch solved two problems by dedicating a specific MAC address to a physical port. If somebody broadcasts something and it doesn't have anything to do with anybody else here except the one port over there, right here, it's dropped on all these other ports. The switch says, well, that's not for anybody else. It's for this port exclusively. Okay. That's what's going on with a switch function. It isolates the traffic that's tagged with the MAC address on layer 2 in the frame and delivers it to that specific port that's physical port that's associated with that. Now that's how it works. I'm not even getting to the Wireshark piece yet. On the other side of the fence, each host has an Ethernet interface, a physical Ethernet interface, and in like fashion, in order to enhance the network efficiency and security, the network interface on each host, a lot of the network drivers and the network services and protocols have been fine-tuned or tweaked so that if there's other stuff that comes through, let's say that this is connected to a hub instead of a switch, better drivers for network cards in a server configuration, for example, there's all sorts of extra attributes and features you can turn up or down, right? There's options you can enable and disable. And essentially, if there's extra trash in the mix from other MAC addresses, right? Are we in promiscuous mode by default? No. So if you are, in the early days of networking, they didn't have such distinctions. Those distinctions really didn't exist, predating the advent of the invention of the switch, right? So if you just had a network card, again, it was broadcast. It was just, everybody was open to everybody. And the simple truth is, nowadays, it's a different picture. And each network interface has additional features where it doesn't operate where it tries to listen to everything. Now, when I put this in bridged mode and I change this to allow VMs or allow all, I'm saying all the devices on the local broadcast domain where I am. If I say only VMs, I'm saying only other virtual machines on the network. So that's one nice feature of the network interface configuration for a virtual machine. But on a physical machine, depending on the driver, depending on the operating system, and depending on the manufacturer, you may or may not have the option to choose or select some of these things. And in terms of how old it is, right? So everybody's mileage may vary. In general, it's not a good idea to turn promiscuous mode up to allow all, because what you're doing is you're setting your NIC to behave like a very old-timey network card. You're saying, okay, I want you to work in grandfather mode, old school mode, right? So promiscuous means, hey, let me see everything, right? Any questions about, does that help flesh out a little more landscape about the concept of promiscuous versus not, right? Does that help? Yes, no, maybe?
Yeah, it does.
Okay, all right. So when we get back to here, one of the things that is a favorite ploy. Now, when the switch came along, hackers were frustrated. And in early versions of switches, the firmware was configured so that it had a fail-safe, where if the network was stressed under certain conditions, it would default back to a hub mode. What am I saying? If certain conditions prevailed on early switches, the intentional filtration and isolation of dedicated traffic to an exclusive MAC address would halt, and the entire switch would fail back into what's called like hub mode or default mode. Hackers found out about this, and they created artificial conditions. In some cases, one of the conditions before they fixed this was that they could jam a port with excessive amounts of traffic and flood so many ports, and it would trigger that condition. And then the switch would change its mode of operation without the network administrator understanding what's going on. And then all of a sudden, all the traffic on all the ports is, well, everybody sees everything, right? So you short circuit the intentional design of the switch. Now, updates to the firmware and security measures have reduced the opportunity for that kind of exploit, but everybody's mileage varies. Everybody has older switches in certain places. Not everybody updates their firmware. Not everybody replaces the switch as long as it keeps working. They keep leaving it in there. That's because everybody thinks because they're driven by money. It's all about money. It's the CFO, it's the chief financial officer who says, yeah, we bought that 3 years ago, and our depreciation cycle requires 7 years of use before we can replace it. And I'm like, what? You're going to replace the switch when our operational conditions dictate, whether you think we need to keep using it for 7 years or not. Unless you want to explain to the board of trustees in our corporation, or you want to explain to the president that he can't do his email or browse the web because you don't have $1,000 for a new model of switch. Okay. And that's where tech and finance need to work together cooperatively and collaboratively. And that's where risk management is premier. In your intro to cyber course, we talked about how risk translates cyber technical terms into a language of money. And what happens when this exploit hits or event hits or this incident hits? Here's what it means in dollars and cents. Here's the loss of productivity. Here's the cost per event. Here's the cost for the year. Here's how many times it could happen each month. Here's what it would cost in operational deficits. It would cost $50,000 estimated in operational deficits. Do you have $1,000 to replace this now? Yeah. And see, I'm extrapolating. I'm kind of expanding on the review of this topic in particular, because you may find that your ability to use Wireshark is limited only because people are cheapskates. And you need to be able to, well, and that's not a fair term. They're frugal. They're wisely managing the budgets and funds of an organization, and that is dignified. And yes, people want their paychecks. You want your paycheck as a forensics consultant. So the main point is that you have to learn to speak the language and do not relent. I mean, do not fade out. Don't let them squelch you. If they don't get it at first, come back from a different angle. Help them to understand with a diagram, a whiteboard. You can tag in another consultant who's a network management expert, even though you're the forensic expert, right? You know what you need on the network, but that doesn't mean you have to be a network expert to make it happen. You have to be able to explain to the network manager what you need and why you need it, right? Okay, so what we're going to do now is pivot and talk about the SIEM. Wireshark is a network sniffer. That's different than a log. So a sniffer is going to capture all of the network traffic on all the ports. That's going to create a huge data file. But let's pretend that this was a managed switch, right? It's a managed switch, and that's the type of switch that would be capable of doing a span port, right? It'll have port mirroring, and you'll be able to set up a span port, which enables port mirroring. And in simple terms, that managed switch is going to have management features like logging capabilities, okay? A managed switch includes the capacity to log certain types of traffic, the capacity to measure the bandwidth for certain applications, how much web traffic, how much email traffic, and so on. The thing that I'm trying to impress on you is that this is just a switch, and there's an awful lot of data that can be collected about network behavior. And oftentimes when you have a very slow network, all you have to do is pull a log report on the switch to see, okay, which port is flooded, which port is pushing all this upstream traffic. Nobody else is pushing upstream traffic, but which port is it? It's those reports and those logs that give you the definition and picture. In order for you to be able to operate effectively in a cyber security context, never mind digital forensics, you need to be able to capture that log and be able to review it in a sensible manner. But then you also have other sources of information like Wireshark, which isn't a log capture, it is a traffic capture, traffic as a whole capture, totally different. And then with our systems, we shared with you that you have system logs, yes? So we did cover this before. Didn't we go into system logs and washing the logs? Yes, no, maybe?
Yeah, we did to cover the tracks.
Okay, right. And so part of the forensic methods, you have two main focuses. You have two main realms of resources. And so when you're talking about forensic methods, you have to know your tools and you have to know your enemy. You know your tools and you know your enemy. And then the choice of tool is predicated upon or based upon the kind of scenario where your adversary or the forensic interests, operate. So what are we saying? You know what the tools are and what they do, and then you also know the adversary and what their tactics are. And then oftentimes your choice of tool selection is based on, okay, what bad actor is likely in this case. In a network scenario, you have to be able to track certain amounts of log ports. On each system, on client systems, and on servers, there are Windows logs. You have a security system where people are trying to log in locally. But then on a server, you could have a domain controller that's tracking, it has a security log and it's tracking domain account logins, not local security account logins. Does everybody understand the difference? So the local security log on the system itself would track attempts to log in with a local account, like a root account, but then the domain controller in an AD setting, Active Directory setting, did we or did we not cover the SAM? Did we talk about security account management, workgroup standalone mode versus domain? Wasn't that in the previous? We touched on that? Yes, no, maybe?
I think so.
Yeah, it's in there somewhere. Yeah. So we have a domain controller that's tracking login events, right? User accounts, audit success, credentials were read. So on a file server, if it's reading user credentials, what that means is that the login account ticket, for lack of a better term, but I think that's actually the precise term that's used in some contexts, that ticket, in fact, it's a Kerberos ticket. In a domain environment, it's called a Kerberos ticket. When you're accessing a shared folder, it's reading your user privileges and permissions. It's reading your user privileges, and then it's looking at what's allowed on that file system object in terms of permissions, and it's comparing what's happening. So credentials are being read all the time with activity, not just for logins, but if you're creating files, changing files, modifying files, it's the operating system is keeping track of what's going on with credentials all the time, and your use of your account. The use of your account and your credentials is what's tracked in the logs. Now, there's an awful lot of traffic that can happen for a secure environment, and what you want to do is filter those results for a failed attempt, or the kinds of behaviors that would tend to indicate a hack is in progress. Now that gets tricky if you have local logs. On my system, I have a local log. If this laptop were part of a domain, you would have the domain logs. Then you'd have network logs with the network switch. You'd also have other logs on the network for the layer 3 IP environment, right? The network address environment, not just the MAC address environment, but the IP environment. And that's a very basic scenario. It gets incredibly interesting when you start turning up the dials, and you need to deal with all of the logs. This is where the SIEM comes into play. So we mentioned this before, and tools like Splunk. So a SIEM is a way to capture different logs from the relevant systems, the infrastructure, the servers and connected network clients, all of the logs that are playing out. When you set up and configure a SIEM, you're integrating the log collection and analysis. One of the most tragic things that happens in an exploit with bad actors is that they do find ways, even though it's more difficult to delete the logs, they will destroy logs, or they will modify logs, right? Or they will change as we've already shown you, they'll change the properties. If they can elevate their privilege, they will change, they'll use administrative access to change, or they'll modify the permissions on that object. They'll find a way to modify the permissions on the security log to allow their lowly account to write changes or change properties. If they change properties so that the log will only hold so many bytes of data, but there's all this activity going on, then it's constantly washing itself, right? It's like a waterfall that just keeps looping the water. It's called a vortex, right? A vertical is the other term for it. It's like a horizontal whirlpool. It just keeps washing that log clean, clean, clean. You never get any detail. So by far, if you are serving a mid-sized to larger organization, and by mid-size, I mean, by the time you get to 24 employees or more, if you are working to support an organization with 24 employees or larger, you must recommend a domain environment if they don't have one, an Active Directory domain environment. And you also want to say, look, while we're doing this and setting it up, we have to work a SIEM. Now, a SIEM sometimes includes data analysis or log analysis tools. In other cases, the SIEM, depending on the manufacturer or product line, a SIEM will only collect the system logs and only the log criteria that are specified. So they'll only collect like you know, a system failure for a critical service, if it's a server, or they'll only track critical changes to an enterprise database, and that's an application log, right? So the thing is, your mileage varies tremendously, and some SIEMs include the tools to analyze the logs that are collected and others do not. In that case, Splunk or NoSQL methods. So there's a whole variety of new tools in data science. This has to do with data mining. There's a company named Splunk. The word Splunk has to do with cave. You explore a cave, you're splunking. That's where the term comes from. So if you are a cave explorer and you're looking for hidden treasure, you like to splunk. And so that's the name of the product, right? And what the product does is it is very good at finding needles in haystacks. It's very good at analyzing and filtering and sifting and sorting and queries, especially for data sets that differ or data sets that aren't consistent. And that's the key. You see, a log format that is specific and unique and configured in a manner that is, can everybody see this here? So this window shows you the content of the log, but you can go into details. And if you go into details, what you're looking at is the XML version of the log entry or XML tags associated, right? Oh, and that's my user security ID number. So you can tell this is, you know, Windows 10 or Windows 11 machine. If you see a security ID that ends in 1001, that is the original root account that's set up. That's the friendly view, right? But look, there's an XML view. And XML has all sorts of tags with all sorts of additional data. The point I'm trying to make here is that Microsoft has a specific format and they have specific criteria for the way they work their logs. But that doesn't mean that the network people, Cisco, do the same, right? They could have a text file, all right? And the router that connects to the internet, that could be a different brand, a different model, a different manufacturer. They have a different format for all their data. So, I mean, do you have to become like a database expert? Well, yes and no. The trick is to understand that there are tools that are NoSQL tools where data is carried and used in a variety of formats that differ, and you still have to find the needle in the haystack. You have to find the event specific that helps you trace the next step in your forensics, right? And these are things that have to be set up in advance, which is why SCCM, Microsoft, right? We talk about baseline, Microsoft SCCM, System Center Configuration Management. So it's like a dashboard. That's what the other C was. I was trying to remember what the other C was. WSIS is a tool that helps push updates so that machines are not exposed because they're not updated. That's Windows Software Update Services. That's a baseline tool technically. This helps you establish a baseline of configuration, but part of System Center Configuration Management includes SIEM capabilities for the additional versions and modules. So it's kind of like a scaled product. They have SCCM in different flavors, and each of them, and this is, I'm talking about what I know from years past. Every year, Microsoft figures out how to remarket, rebrand, reconfigure this so that they can.
I'll go right after my last class, which is
they have another chance to sell a product.
one-ish.
Was there a question?
Oh, sorry.
Okay, no problem. Are there any questions about what a seam is and does? The term seam. If you look in your appendix, so some of the stuff that I'm looking at, I'm also pulling from the appendix. Addendum, I mean. So in here, you also have an addendum. And this is, by the way, there are new versions of the addendum and the study guide where we added additional information, right? So you need to know your tools and then know your enemy. So know thy tools and then know thy enemy. And this is part of this reference in combination with the forensic tool taxonomy here. If you're familiar with each of these resources and what they do and how things work, if your hacker is accessing the contents of live RAM in the hopes of afflicting your system with a buffer overflow attack or a SQL injection or something like that, oftentimes the information you're looking for is in live memory. So when you're looking at the tool and its purpose, the purpose column is really helpful, right? What's the purpose of EnCase? Now, this is my interpretation of EnCase's purpose. If you're running EnCase, you're a corporation or a government agency, and you're monitoring a huge amount of information on user activity. That's what EnCase does. And it establishes a baseline, and when things don't track with the baseline, it automatically flags an EnCase specialist, who is also often a digital forensic specialist, right? And it starts collecting data. It starts, oh, hey, we were at a porn site. Oh, now we wipe the cache in the web browser, right? So those kinds of things are happening with an EnCase environment. It's very expensive, but it's for companies that take the misuse and abuse of their technology resources very, very seriously, especially where there's a lot of industrial espionage. So you'll find EnCase in use in places like Department of Defense contractors, or actually healthcare environments, where you have to make sure that employees are not fraudulently accessing medical records that they don't have a cause to access. One of the things about HIPAA is that you control healthcare records so that people that have no business looking at your healthcare record do not look at your healthcare record. One requirement of HIPAA is that a patient may request, and I want you to hear this. Is everybody with me?
Yeah.
Okay, yeah, I need everybody to unmute your mic and say, yep, I'm with you. I'm ready to hear this next piece.
I'm with you.
Yep, I'm here.
Okay. So you would find EnCase in a healthcare context, potentially. Why? Let's say that you have a nosy nurse or doctor, and they're really interested in a patient, but they're not involved in the care of that patient, right? Any patient under HIPAA can request a report of who accessed their medical record. Let me repeat that. Any patient anywhere since the late 1900s, right, can request a report from a hospital or a doctor's office or a dentist office. Who has accessed my medical information? It is their right. Now, if a company is found in violation of HIPAA, there are jail terms. It's not a matter of like, okay, we're going to court, somebody's going to sue us. That's not what we're talking about. There are criminal charges, there are criminal violations, felony violations, 5-year minimum sentences, right, for certain things. $50,000 per occurrence. So if you have somebody that's in the weeds and they're helping themselves to, oh, wow, that's a really sexy patient. I want to look up the specifics about that sexy patient. I want to know things about them, where they live, what they do, what their medical stuff is all about, right? See, people misuse and abuse systems, and integrated healthcare management systems have those features built in, but in many cases they don't. An EnCase is an ideal method for tracking that kind of stuff. Quite often it's disciplinary action and or separation from the organization, better known as termination or fired. That is the end result when EnCase is in the mix, and EAT is not a deliberate, intentional, repeated thing for all the employees. We forget. We get on the screen, we get in our browsers, we get in our email, we see a flashy little blingy thing we're looking at, and before you know it, we're in not safe for work, not safe for work, not safe for work websites. This triggers logs. Those logs automatically notify people. It's like a heat-seeking missile. And then the real question is, okay, what happens next? Extensive EAT. Does everybody see the word extensive? That's not just for the people using EnCase. That's people who are using systems that have it running in the system tray here. Okay. Again, acceptable use policy. If embedded in the acceptable use policy, you have a statement that says, we are required by federal law to monitor the access of electronic and digital healthcare records. For this reason, we have to track who's getting what information. We are always taking account of who's into what Kool-Aid. See, that's part of the acceptable use policy. In the education and awareness training session with your employees, when you're onboarding your employees, you have a record of expectations that's in place so that when EnCase trips and flips, and you have to use the record from EnCase to terminate an employee, there's no surprise. Everybody knew it was coming. This is how it works, right? So baseline, I have it listed under baseline, but EnCase is also an acquisition tool. EnCase is also an analysis tool. EnCase is also a reporting tool. EnCase also has forensic capabilities. EnCase is like the Swiss Army knife of forensic tools. And you could specialize. One thing about it is if you train with EnCase and then become EnCase certified, there are lots of very high paying corporate jobs that become available to you that no one else can work. So I don't want to sound like EnCase is like Big Brother and it's evil. It's Big Brother, and it has a very important role to play in establishing a baseline, acquiring forensic information, analyzing information. And that's one aspect of this taxonomy that I could revise, but it gets to be a little repetitive. If I take the forensic toolkit imager, if I take the forensic toolkit generically, not the imager. The imager is a component that acquires data for disks, okay? So that specific product is part of a suite of tools. If I just take forensic toolkit, FTK, I run into the same conundrum. FTK has tools that can be helpful in establishing a baseline. FTK as a suite of tools has resources to capture or acquire disk data and memory, right? FTK as a suite of tools can be used to analyze, to report, right? So that's where we get to this part right here. I wanted to point out to you that instead of repeating a listing, 15 different times, right, for baseline, acquisition, analysis, all the different phases of digital forensics work, you could have all of those entries in each of these categories, and it gets to be really tedious, right? Now, there are open source forensic suites that are still around. Kali is an exception because Kali does not only work forensics. Kali includes hacking tools for penetration testing or for ethical hacking. Kali is used by bad people as well as good people. But Kali includes a suite of forensic tools along with all of the other tools. When you turn up Kali in the environment, you need to let people know, hey, I'm using Kali. Because if people don't understand, if that signature shows up on the infrastructure, if they have other things running in the environment, like, I don't know, log integration and event management tools, that's what the SIEM stands for. So the SIEM acronym has to do with security, information, and event management. Now, you're going to see variations of this acronym. I've seen SEIM, I've seen SIEM, and I like to call it SIEM because it's IE, and they're saying, oh, it's pronounced SIM, but no, tomato, tomato. Right? SEM is security event management. Security information management is SIM. That sounds like SIM to me. SIM, and SIEM. That's how I choose to pronounce these. And okay, so according to Microsoft, this is how they choose to define it. You're going to find differences everywhere. So depending on the company, they may choose to relate their product, as a log consolidation and analysis tool. A logging consolidation and analysis tool is essentially what a SIEM is and does. It consolidates the logs and it helps with analysis of the logs. And if it's a original generation SIEM, it's weak on the analysis tools, but it collects like a Banshee. What does that imply about the taxonomy of tools? You better have terabytes and terabytes, and not gigabytes, terabytes and petabytes. 1,000 terabytes is a petabyte. You're going to need a storage area network or a NAS that comes close to like 500 terabytes, right? Which would be half a petabyte, I believe. Or exabyte. Which is it? Let's make sure we don't steer you wrong. Maybe it's exa, peta. Okay, here it is. Mega, giga, tera, peta, exa. So exa comes after peta. Petabyte is a hell of a lot of data. Okay, so it's a 1024 terabytes. If you have 1,024 terabytes, that's a pretty big storage area network or a pretty big NAS, right? Does everybody follow what I'm saying? And why would you need that much storage? Well, if you have 24 or more employees and your security and forensic interests are significant and serious, let's say you have a professional consultancy. It's a legal partnership that specializes in technology cases and technology law and cyber law. Or you have a forensic consultancy and you have 24 employees. You'll need huge amounts of information. That has to be part of the taxonomy of forensic tools and resources and methods, because in order to work with some of these, you're going to have a lot more. And that's where I probably need to update the prerequisites column and then annotate a little bit in the limitations column where we call out some things more intentionally about some of the tools. You know, Splunk, did I say with Splunk that it costly licensing, specialized training? Oh, and I should probably add lots and lots of disk space, right? So if you're going to be capturing gobs and gobs, it is frightening to see the amount of log data that is generated by 24 machines where security is a serious interest. Law enforcement, CSI, if you have a law enforcement CSI department and there are 12 employees, you're looking at an interest that could easily scale to petabytes of data storage, right? Now, notice this one, Explico for analysis. This one is specifically intended for network protocol and application analyzer, web traffic, email traffic, TCP traffic, SQL traffic, etc. Now, that differs from a tool like Snort. Has anyone ever heard of Snort? Snort?
I don't think so.
I don't think I have.
Okay. So this is kind of cool, but we've talked about network sniffer, right? And let's say that you have a network sniffer that can capture all the traffic on all the ports. Everybody with me so far? A network sniffer. You turn up all the dials with your Wireshark, and now your Wireshark is sniffing like crazy, right? And then you add analysis, live analysis, interactive capabilities while it's happening live. And what you're searching for are anomalies in the network traffic. So you're analyzing the network traffic that you are sniffing across all the ports. What we have just described is called an intrusion detection system. Have you heard of this?
Yeah, we've talked about it before.
Right. Now, there's also the same kind of thing on steroids. It's called an intrusion protection system, or IPS. So if it's just detecting, if you take the functionality of a network sniffer and you combine it with forensic analysis live in streaming fashion with network tools, network analysis tools, then what you're really describing is the IDS. Now, an IPS adds a layer of teeth to the detection. So when you detect a pattern that's going on, and then the IDS alerts and notifies, the IPS can do things like send a TCP reset to break the connection. So you terminate the connection, it's a TCP reset. You're like, yeah, no, you're not on this network. And all you're doing is defending yourself, but you know, intrusion prevention systems or protection systems can include tools for like counteroffensive or defensive interests, right? And this is a handy comparison to understand the difference between IDS and IPS. So, you know, this detects and then monitors and reports. They analyze traffic and compare it to known threats. That's what they do. That's what they both do. But this one can decide whether to accept or reject packets based on rules. And if it says, nope, we're not having this, we're not doing this, sends a TCP reset and it kills the connection. And so people who are on your network, they're like, my connection keeps dropping. I don't know why. Yeah, you want to check the IDS IPS log. There's an open source, which again, as a trend, snort. And so after our session ends in a few minutes, I am gonna, do we see snort in here? I see IDS. See IDS. No, IPS. Now these are more network security tools, but there can be forensic resources that are associated with an IDS and an IPS. And so it's not in the taxonomy of forensic tools and methods because it's not really designated as a forensic tool and method, but it's a useful source of data to analyze, right? So let's see, snort. I think what I'm going to do is choose to address this in our study guide addendum. I think what I'm going to do is add a comment here that speaks to that interest, that says open source tools like Snort, IDS, IPS, firewalls, these are all network security. They're originally designed, and the original interest is to provide to reduce network exposures, and it's a network management, network security tool, but there are components that can provide critical resources to a digital evidence specialist, to a forensic expert, because those logs are a gold mine of information about the activity that's happening live, right? So even though, I mean, if I took this matrix and I added those things, the matrix would start to include, like, a lot of the technology infrastructure, which originally has a different purpose. So in any case, when it comes to limitations and prerequisites, I'm going to tweak this to include very large volumes of disk media, especially where it's very critical, okay? So here, where we talk about Wireshark, where's our Wireshark? Wireshark, I'm going to add, depending on the use of the mirror port and how many clients, you may be dealing with huge amounts of data. And so I'll tweak prerequisites and limitation here to reflect that. Are there any questions about what we've covered to this point? Have we discussed much about hashing? We did review the basics about hashing, correct?
Yeah, we mentioned it, but we haven't gone in depth, I don't think.
Right. Okay. Well, I think the best and most practical way to broach the topic of hashing tools is to use them hands-on. And so in some of the assignments and the solutions upcoming, what will happen is that you'll have to lay hold of the hashing tool. For this solution, you will need to set up, I just want to check something here real quick. I'm pretty sure it's this solution in module 2. You need to set up a Kali system, and in particular, I don't have it posted yet. In particular, what you're going to want to do is use a USB drive to configure a USB bootable Kali thumb drive. Okay. There is also, let me see if we have hex editor in here. So hex editors are a useful tool. And I think I may mention this in the addendum or in the study guide, hex editors. Okay. So a hex editor is a tool that allows you to look at the guts or inside of a digital file. Okay. And slide 14 is used to show the header. So what are we talking about here? Slide 14. Digital tools. Let's see if we can drill this. There we go. Can everybody see that?
Yeah.
Yeah.
Can I add a Miko first?
Yeah, we'll zoom in. How's that?
Oh yeah.
Okay, so this is an indispensable tool, and and some hex editors include additional resources and utilities, so it's almost like a suite of tools. But hex editors tend to stand apart as a forensic resource in the same way that Wireshark. Wireshark is very specialized. It does one thing really well, Nmap, right? There are all sorts of specialty tools that kind of stand apart, and it's not a collection of, it's not a full suite of tools. And hex editor is essential. Yeah, that might be one thing that so it's in the addendum, but I may end up adding a short reference about those in here in the taxonomy. What you see here is an example of a file that a user named bayshot.docx. Okay. And that says, okay, what kind of document am I? What kind of data file am I? What application would likely be a DOCS or a DOC?
A Word document.
A Word document. Yes, thank you. A Word document. So when you take a hex editor and you look at this file on the user machine, it's not a Word document. It's something else. Here's what happens. I'm going to simulate this. Okay. So this is a common favorite method. And now we're getting into that last part of our class. So in our concluding minutes, I want to get to the addendum where we talk about know thy enemy, right? Know the tools and know the enemy. You may have somebody who wants to avoid detection for the things they are doing, right? I mean, that's why they would call you in there, right? So I'm going to take this JPEG file from our last class. And I'm going, this is a JPEG file from our last class. Everybody with me? It's a graphics file. But if I do this, it says, hey, are you sure you want to do this? The file might become unusable. Are you sure you want to change it? I'm going to say, yeah. Now, what does the operating system think the application, the typical application for this file is? What's it going to open it with?
Notepad, I think.
Oh, wow. Okay, that's kind of messy, right? That little graphics file doesn't, it looks weird, doesn't it? Yeah. Well, let's try this. Let's put docx. Now it shows as a Word document. It's unreadable. Do you want to recover the contents? No, I'm going to say no, right? Okay. But what they'll often do is change the extension to try to hide something. Change the extension to try to hide something. And what we want to do is have a look at some data files and look at the header of the file, the metadata of the file. So a hex editor allows you to review the metadata of the file, which includes the file header. In the file header, if you see exif in the header, it means, okay, that's a graphics. That is a graphics data file, not a Word document. Right? So that's somebody's attempt to hide something with a simple method. That's a very common tactic. And so hex editors, you can find hex editors built into Kali, but you can also download WinHex. So it's a Windows hex editor, and you can see this, and that's a tool you can run and use in Windows. It's really cool. So, and it's open source, right? So you can look, you can point it to any data file, and you can look and see things in the header. And there's a simple user guide that says, hey, if it says exif in the header, that's a graphics file. If it says such and such in the header, it's a PDF. If it says such and such in the file, it's so and so, right? And it's a common hacker tactic to simply change it up Charlie so that it's confusing to people, right? Somebody gets on their system, somebody else gets on their system, and they try to open something they're not supposed to. What happens? Oh, all this gibberish comes up on the screen. That would be a pretty annoying thing, but it also might be a pretty disconcerting thing. And the person that's using their system that maybe shouldn't be snooping around in the folders, right? Double clicking to see what's in there. Maybe they get the idea, oops, whoa, what's this? You know what? I'm not comfortable in here anymore. And they might nosy the hell on out of there, right? So there's all sorts of reasons why hackers use that simple method to hide things. They also do silly things like, I don't know, change the registry in Windows so that the name of a file, the file name is in white. The name of the file is in white and the attributes. So when it's listed, you think you have a non-file or a gap. A lot of people look at their file explorer, and if they see an empty line, they don't think anything of it. But somebody changed the color of the file name font to white so they can hide it. Does everybody understand what I'm talking about here? I'd like to take just a quick minute yet, and then I want to accomplish, and does everybody have 60 more seconds or so?
Yeah. Well,
Right.
well,
And if you do have to peel off, I understand. When you're looking at your adversary, know your tools, know your adversary. In some cases, when you're dealing with a criminal, it helps. It's very important to understand the 3 elements of proof: means, motive, and opportunity. When you are working your services as a forensic expert, when you're engaging the evidence, you are engaging the evidence with a view of whether or not that digital artifact, that digital exhibit, because this is a criminal investigation, right? Does it speak to the means required by the criminal? That means, do they have the capacity? Do they have the tools they need to perpetrate the crime? So if you're investigating a suspect in a criminal investigation, the digital artifacts or evidence are going to speak to the means, or they'll speak to the motive. Why is this person, why is the alleged criminal, right? The alleged perpetrator. See, when we're working digital evidence, we're always looking at the evidence objectively to see if it's inculpatory or exculpatory, meaning does it incriminate someone or does it exonerate someone? When you encounter digital evidence on a perpetrator, it may speak to motive based on the nature of the evidence, right? You find information and what is it? You're interpreting this in the context of the environment, right? Opportunity. Does the perpetrator, alleged perpetrator, have the opportunity? Now, if you're dealing with a hacker, and it's obvious you're dealing with a hacker, maybe it's not criminal yet, technically speaking, but it's aggressive and somebody is an uninvited guest, right? And it really helps to frame your review of the evidence. It's like a framework, 3 elements of proof, right? Means, motive, and opportunity. That gets down to the, again, knowing your enemy, knowing the tools, and when you're interpreting the evidence with those tools. Now, let's take a brief moment to consider the solution. The solution for Module 2, I want you to create a live USB. And when you create the live USB, does everybody see this here?
Yes.
This is my virtual machine. You can choose to create a virtual machine that's a Kali Linux system, okay? You can do this, but I would prefer that you, so that's an option. And if you already have that, and you just wanna hit the easy button, that's okay. But that's the alternate solution that I'm going to post. And it could be considered additional credit. So the primary component of the Module 2 solution involves creation of a live Kali USB. Now, there are a couple of tools you can use to create a bootable USB thumb drive, but what you'll need at a minimum is a 16 gig thumb drive, right? And it needs to be a USB 3.0 thumb drive. And the specifics of how to do this and what steps to follow will be in the solution assignment, right? So you'll have that information. But there are a couple of tools that USB. Yummy. I like Yummy. It's also known as the ultimate pen drive. Yummy allows you to configure multiple partitions, multiple booting. That's also true of some of the other tools. Rufus is an older tool. Balena Etcher is a famous one, right? You can choose whichever one you want. I will not dictate which tool you use to create your bootable disk from. But here's the thing I want you to understand. When you add persistence to a Kali Linux live USB drive, what you're doing is you're saying, I want to use my Kali USB drive and I want the storage on this USB drive to be writable. And there are problems with that. What we want you to do for your solution is to download a suitable version of the live distribution for Kali Linux. So it's going to be a live distribution, not a standard distribution. Those are intended for use as a bootable. So you put it on a DVD disc or you put it on a USB drive. You can burn it to a DVD disc or you can put it on a USB drive. And again, you use the tools that we just showed you, Balena Etcher and so on. But those tools will give you the option to create what's called persistence. And what that'll do is it'll write enable the USB thumb drive. And that means that your Kali tools can be modified, corrupted, modified and corrupted while you're using the darn thing for forensic purposes. Do you want a forensic tool to be editable so that a malicious, some malware, or a live actor, even better yet, an advanced persistent threat. Let's say you have a bad actor and you have someone active in the environment. Do you want them to be able to corrupt your Kali Linux tool suite while you are performing forensics? What do you think the answer to that question is?
No.
Actually, yeah, I would say hell no. I'd say that's like a Medea, the Tyler Perry Medea. Hell no, right? You would not want persistence on if you're using Kali Linux as a forensic tool suite, I would recommend that you avoid using persistence. Now, that begs the question, what happens if you want to capture some data and evidence? You connect a separate disk for that. So when you boot into the system using your Kali Linux live USB drive, and you start working it up, you have a separate connection to a separate USB or a separate external hard drive, and that's where you capture the difference, okay? So always remember, if it's a forensic tool suite that your given purpose for that Kali Linux is all about, it's not used for pen testing, it's not used for ethical hacking, it's not used for wireless analysis, right? It's used for forensics. If your forensics to be valid, you do not want to add persistence. Now you can see when you follow this in YouTube, oh my gosh, there are experts that have all sorts of helpful, handy dandy, oh, and be sure you do this and be sure you do that. And I'm like, yeah, no. Yeah, you don't. Because that leads to bad things, right? You want to be able to assert, if put to the test, that what? You're always validating, you're always verifying, you're always authenticating, you're always calibrating, right? You're always testing your tools. And you can't do that if you create a USB thumb drive that's malleable and changeable. You plug it into a system that's infected, God only knows what can happen on your thumb drive within the first few seconds. It's like playing with a loaded gun. All right, so I will post here the solution going into the weekend. I will have a short video to explain some of this, and there will be an assignment document with a rubric. You can work an alternate submission using a VM with Kali for forensic purposes, but that's not the same as using a USB. And I want you to have the experience of actually having a Kali live USB to extract data from a physical source for one of your solutions in a following module. And we can't do that if your Kali is this. I'll allow you to submit it, right? Instead, but I would prefer that you show you have a live USB, persistence is not enabled, and you have, in addition to that, a virtual machine that can be used for like the Wireshark, right? Does everybody understand what I'm saying?
Yeah.
Any questions before we close out our session today?
No questions.
Thank you for your patience with the delayed start and the delayed closure. We will do better next week and from here on out. There have been a lot of unusual things flapping around in the last couple of weeks. So I do appreciate your patience. I hope you have a good weekend. And if you have any questions about what you see in the solution, don't hesitate to send me a quick email.